Welcome to the second lab video in preparation for Lab 8. The first video covered heart structures and the flow of blood through the heart. This video will discuss blood and blood typing. So recall from our early histology days that blood is in fact a connective tissue. It is a connective tissue because it contains loosely arranged cells contained in a ground substance. In this case, is a liquid ground substance referred to as plasma. And in that ground substance, there are proteins. These proteins are primarily involved in blood clotting. Blood is thicker than water and runs about 1 degree Celsius warmer than your body temperature. The components of blood can be rather easily broken down using a centrifuge, as I'll show you here. Taking some blood, typically from the antecubital region, and putting that blood into a tube, centrifuging that tube for about 10 minutes. What you'll find is that the blood will separate out into its main components. On the top, it'll be the plasma. It accounts for about 55% of the total blood volume. It is primarily water. In the middle, there's a very thin layer called the buffy coat. That is where the white blood cells and the platelets will pellet out. The bottom will be the red blood cells, the erythrocytes. They're going to account for roughly 44% of the total blood volume. So again, just to put this into words, the plasma would be on top. It's a straw-colored, sort of a very light yellow-colored layer. It is, again, mostly water, about 92% water. It also contains some proteins in there. And it also contains nutrients, enzymes, waste products, gases. Basically, everything that's dissolved in blood and carried in blood is going to be in that plasma component. In the middle, again, is that buffy coat, white blood cells and platelets. This is a relatively small percentage of the sample volume. And then finally on the bottom, red blood cells or the erythrocytes, accounting for about 44%. Let's take just one closer look at this. You'll also see this in lecture. This gives you a breakdown of the proteins that are found in blood. That will not be our focus today, but we will pick up on that in lecture. In the buffy coat, there are platelets and white blood cells. White blood cells come in 5 basic types. We will not be focusing on that in this lab, but these are the neutrophils, monocytes, eosinophils, basophils, and lymphocytes. That conversation will be had at a different time. And then in the bottom, you find the erythrocytes. I just want to point out the number of cells here. This is pretty mind-boggling. It's saying that there's 4.2 to 6.2 million red blood cells per cubic millimeter. So what is a cubic millimeter? Imagine a little box, right? Little cube. And each of those sides is 1 millimeter in size. So we're talking about a very, very small little cube. The amount of blood that would fill up that cube, right? If you had that cube filled up with blood, that would be a cubic millimeter. But that also happens to be equal to a microliter of volume. That's 1/1,000,000th of a liter. So in a very, very small drop of blood, one would find 4 to 6 million red blood cells. Pretty astronomical. So let me describe this one more time. So in the blood, you have the red blood cells, the erythrocytes. In addition to the erythrocytes, there are the components of the buffy coat, that is the platelets and the leukocytes. Together, all of those 3 things, erythrocytes, platelets, and leukocytes, are referred to as the formed elements. And the reason is that platelets are not cells. They're fragments of cells. So to call these just blood cells would be a little bit misleading. So all of those components, red cells, white cells, and platelets, are collectively called the formed elements. When you take those formed elements and you add the plasma, that's whole blood. So when you go to the Red Cross and you give blood, you're giving whole blood. They're taking everything. You can also go to the plasma center. You go to the plasma center and they're only taking plasma. So they're going to take whole blood. They're going to return the blood cells to you, the formed elements, and they are going to capture the plasma. Another term you probably heard about is serum. Serum is plasma without the clotting proteins, but it still has all of the other goodies found in the plasma. So it still has antibodies, antigens, hormones, enzymes, electrolytes. This plasma, when you go to the plasma center, is used for all sorts of medical, treating all sorts of medical conditions. And right now we're hearing about COVID, and we're hearing about those who have already been exposed to COVID may have antibodies in their blood that can be given to somebody else as a way of fighting off the virus. And so you can see that the antibodies would be part of that plasma. So what blood does, not too difficult to imagine. Blood is carrying all sorts of things. The red blood cells are primarily carrying oxygen. They also carry some carbon dioxide, the gases. The plasma itself, as it travels through the body, is carrying nutrients and hormones, waste products. So the plasma is really carrying quite a bit of materials. Everything that you carry through your blood is dissolved in the plasma. Let's get another sense of these numbers. So 99% or more of all of your formed elements are red blood cells. They have a lifespan of about 120 days, so about 4 months. Their job, again, is to transport gases, oxygen and CO2. And here are their numbers: 4.8 to 5.5 million red blood cells per microliter of blood. Now, it could be higher or it could be lower, but this is just sort of in the middle of those ranges. We'll see in a minute that men have more red blood cells per microliter of blood than women on average. Secondly, the white blood cells, they actually account for a very small percentage of all of the formed elements. They're relatively rare. Their job is not to carry oxygen, but their job is to fight against foreign bodies, against viruses and parasites and bacteria. Leukocytes have a relatively short lifespan, all the way up to providing immunity for all of your life, lifetime immunity. So their lifespan is varied from hours to years. Their numbers, as you can see, compared to the millions of red blood cells, are relatively rare. Only 5 to 10,000 white blood cells per microliter of blood. Finally, the platelets, they make up a very small percentage as well, right? Less than 1% of all the formed elements. They are directly involved in blood clotting. They hang around for only about 8 to 10 days, so they relatively short time in your blood. And by numbers, they're somewhere in the hundreds of thousands. So 120 to 300,000 or so platelets per microliter of blood. One important measurement that you'll hear about is hematocrit. Hematocrit is actually what percentage of your blood, so if I took some of your blood and I spun it down in a centrifuge, what percentage of your blood volume is made up of red blood cells? And that would be, that percentage of red blood cells would be considered your hematocrit. Now, hematocrit values vary quite a bit. In males, a normal hematocrit is going to be between 42% and 54%. So I always remember somewhere around 50%, just as a reminder, okay? Just roughly 50% of a man's blood is made up of red blood cells. Women, though, are lower. And you'll see that they're in more like around 40%. Now, again, this is just a rough estimate for me to remember these, but around 40 to 45%, right, would be a female. There is some overlap here, but more often than not, men will have a higher hematocrit than a woman. Now, for children, the numbers are all over the place. I provide these numbers not for you to memorize, but just to see that the hematocrit values change, especially in the early years of life, rather significantly. And one last thing is that altitude can affect hematocrit rather significantly. If you are in a high altitude place where there's less atmospheric pressure, then your body will compensate by making more erythrocytes. So if you live in Denver, you are going to have more erythrocytes than a person living in Michigan. And as a result, a person's average hematocrit in Denver will be higher than a person who lives here. There is a hormone produced by the kidneys. You'll hear about this again when we get to the urinary system. But this hormone is erythropoietin, or erythropoietin. It's abbreviated EPO. And this hormone, as the name suggests, is a protein. It ends in IN. POE, formation of red blood cells. So this is the hormone produced by the kidneys that causes the body to create more red blood cells in response to low blood oxygen. A couple more facts about red blood cells that you may not know. Red blood cells, mature red blood cells, do not have a nucleus. So that tells us immediately that they cannot divide. They don't have DNA. They don't have a full metabolism. Their job is simply to transport oxygen and CO2 throughout the body. Because they don't have a nucleus, this actually makes them more efficient. They're not actually using up energy as they travel through the body. They are said to be biconcave in shape. You'll see that in a moment. They travel through the smallest of blood vessels, and sometimes this requires them to be very flexible and for them to even line up in a single file. You'll see that in a moment. And because they can't go through mitosis, they don't have a nucleus, they don't have DNA, they can't replace or repair themselves. So as I mentioned again, they only have a lifespan of about 120 days, which means roughly 1% of all of your red blood cells are being broken down or phagocytosed every day. This happens in the liver and in the spleen. So the liver and the spleen contain a lot of macrophages, which are going to be phagocytosing broken down red blood cells. Here's what I mean by that biconcave shape. You see here that there's a double indentation. It looks like a dog bone, right? So the fact that there are two indentations, right, biconcave, one on each side. The other thing I want you to take note of, besides the shape, is the diameter. So the diameter of red blood cells is about 7.5 micrometers. That measure is really a nice indicator when you're looking at a tissue through the microscope and there's any blood in that histological image. It's basically like having a little ruler right there in your microscope. You know that that is about 7.5 micrometers across. So that's a nice measurement, one I want you to know. Now, what is it that actually carries the oxygen in red blood cells? There's a protein called hemoglobin, right? Ends in IN, it's a protein. And every one of your red blood cells is filled with about 280 million molecules of this pigment called hemoglobin. A pigment is a colored molecule. In this case, it's a red colored protein called hemoglobin that, oh, by the way, binds and carries both oxygen and CO2. Turns out that when oxygen is bound to hemoglobin, that hemoglobin becomes bright red. That's what gives your blood the bright red color. However, when there is less oxygen around, so either no oxygen or less oxygen around, then the hemoglobin is no longer bright red, but more of a deep red color, more like a brick brown or a brick red color. And we perceive that color as blue through our skin. And that's where we get the idea that venous blood, right? Venous blood is blue. So to recap the life cycle of a red blood cell, you know that red blood cells are produced in the red bone marrow, right? So here's the head of the humerus, and we know that that's where hematopoiesis occurs. That blood, those blood cells are going to travel through your body in the blood vessels for about 120 days. As they get tired and worn out, they're going to be broken down by macrophages, phagocytic cells found in the spleen and the liver. In that recycling process, the iron will actually be reused. So there's iron involved in red blood cells. And so some of this is going to be recycled and brought back into the bone marrow to make new red blood cells. Some of it, a molecule called heme, is actually going to be converted through a number of really interesting steps and will be secreted in the bile from your liver that we talked about a little bit last week in the digestive system. And also some of this heme ends up eventually creating some of the dark coloring seen in the feces. One of the things I mentioned is that blood carries antibodies. So let's describe what antibodies are in the general sense, and then we're going to take this conversation to better understand blood typing. So your body has an amazing lymphatic system, a system that is unique to you, that is designed to fight off and destroy anything that comes into your body that is deemed dangerous, deemed foreign to you. Essentially, our immune system is trained to look around and say, okay, everything I'm seeing right now that is in my body is normal, is self. And so the immune system would not want to create antibodies that would attack itself. Now, in some people, there are antibodies that attack self, and those are called the autoimmune diseases, not the ideal situation. But typically, those autoimmune diseases are not going to occur, and instead our body only makes antibodies that would fight off foreign things. Those foreign things that enter our body are called antigens. So, in the same idea, in our blood cells, we have three particular antigen markers, three particular protein sugar group molecules that are found on the surface of red blood cells. Our entire blood typing system is based upon whether or not you inherited or did not inherit some of these blood surface antigens. And these antigens are there's the A antigen, there's the B antigen, and there's the Rh antigen. And it turns out that you inherited the A, or you didn't from your parents. You did or did not inherit the B antigen, and you did or did not inherit the Rh antigen. If you did inherit it, then your body is accustomed to it and would not make an antibody against it. But if you were to receive blood from someone who had a different blood type than you, that blood antigen coming into your body would trigger your immune system and would cause antibodies already made by your immune system to search out and destroy that foreign blood type. So in your own body, the antibodies in your blood plasma do not recognize your own red blood cells, but do recognize blood types different than yours that might enter into your bloodstream. So in this slide, you're looking at a red blood cell, a cartoon of a red blood cell. And on the surface of this red blood cell, this square structure represents the A antigen. This triangle represents the B antigen. And this little Lincoln log piece right here represents the RH antigen. So if you have inherited all three of these antigens from your parents, then you are said to be AB positive in your blood type. A, because you have the A antigen, B, because you've inherited the B antigen, and RH antigen gives us the plus sign. Now, some people would not have all three of these. Some people would be born having only inherited just the A or just the B, or maybe the A and the RH. So as a result, there are 8 different blood types. 8 different blood types. And we'll figure out what those are here in just a moment. So how does this work? On the surface of your red blood cells, you have inherited, perhaps you've inherited the A antigen from your parents. And if you do, it's shown here in these little blue dots. And they would be all over the surface of your red blood cells. If you inherited the B antigen, then you would have, in this cartoon, these purple spikes. You could inherit both of them, in which case you would have a mixture of both the blue dots and the purple spikes on the surface of your red blood cells. Or you could have inherited neither, in which case you have naked little red blood cells. You also could have inherited the RH factor, sometimes called antigen D, shown here as the blue rectangles, or maybe you didn't inherit it. Okay. Now, if you did inherit the A antigen, then your body would naturally make antibodies against B blood. We would say you make anti-B antibodies. If instead you inherited B blood, you would naturally make antibodies against A blood. If you inherited both of these antigens, you would not make either of those antibodies. And if you did not inherit either, then both A and B would be foreign, and you would make antibodies against both A and B. Likewise, if you inherited the D antigen, you would not make antibodies against it. And if you did not make it, you would produce antibodies against RH. If you inherited only the A antigen, then you have type A blood. If you inherited just the B antigen, you have type B blood. If you inherited both, you have AB blood. If you have inherited neither, you have type O blood. So think of the O as a null sign, a 0. You did not inherit either one. And then, on top of that, if you inherited the RH factor, we're going to say you have a positive blood type. If you did not inherit the RH factor, you have a negative blood type. Of the 8 blood types, 2 of special note. If you have O negative blood, you are the universal donor. If you have AB positive blood, you are the universal acceptor. Let's think about this for a second. O negative blood is the kind of blood that they're going to carry in the emergency room, they're going to carry in the ambulance in greatest amounts. Think about what that O negative blood is. It is a red blood cell that has not inherited the A, it has not inherited the B, and it has not inherited the RH factor. So in essence, this is a naked little red blood cell, and because of that, it can be given to anyone in an emergency, and it will not be rejected by that person's immune system. So if you have O negative blood, you are very popular with the blood center. They want you, they want your blood in high numbers. Now, if you have AB positive blood, that means that you look like that red blood cell a moment ago. You have, on the surface of your red blood cells, you have the A, you have the B, and you have the RH. Well, because your blood already has all 3 of these antigens, and because your body's already accustomed to that, a person with AB positive blood can receive any of the 8 blood types safely. Because their body says, hey, I'm used to seeing all of these things. I can handle A, I can handle B, and I can handle RH. So a person with AB positive blood, their blood is not really needed by the blood center. Because, as we'll see in a moment, AB positive blood can only be given to other people with AB positive blood. Those individuals are relatively rare, and because these individuals can receive blood from anyone, it doesn't make a lot of sense to stock a lot of AB positive blood in the blood bank for emergencies. Now, how is blood typing going to be measured? What one does is we take some blood. So on this piece of cardboard, there's a smear of blood, and added to the blood are some antibodies. Now, these antibodies are something that you can commercially purchase. So in this case, we have type A blood, and on the surface, there are the A antigens. And we add to it anti-B antibodies. So these B antibodies would bind to B antigens on the surface of the red blood cell, but there aren't any. And so there is no binding. There's no binding going on. And as a result, when you do this, you do not see what we call agglutination. You do not see any clumping of the antibody antigen together. And so you just get smeary blood. But what if you had type A blood and you added anti-A antibodies? Now, these antibodies are going to find and attach to these antigens, causing a clumping to occur. And visibly, you will see what's called agglutination occur. So when figuring out your blood type, you see agglutination. Let's think about this in a different way. This person has type B blood. Okay, they have type B blood. All of these red blood cells, right? All these red blood cells that we're seeing in this guy's arm, these are all red blood cells that have on the surface the B antigen, right? These are his normal red blood cells. But somebody messed up, and they are giving this person type A blood. In this picture, the purple red blood cells are the type A. They are the foreign red blood cells mixing in now with his blood. So what happens? Well, notice that in the background of this cartoon, you can see these little yellow slingshot molecules. These little yellow slingshot molecules are antibodies. Now, you carry thousands of different antibodies in your blood, but some of them, if you were this guy, some of those antibodies would be against A blood. You would have antibodies against the A antigen. And so, all of a sudden, that foreign blood coming in, A blood, is going to meet up with some of these anti-A antibodies and is going to cause clumping to occur. These clumps, right, are dangerous, and they are able to block the blood flow into smaller vessels. Well, what's down here? If this is the kidney, right, if this is the vital organ, then you have blocked blood flow to that vital organ. So by giving someone the wrong blood type, you actually can cause significant tissue and organ damage depending upon where these agglutination reactions occur. What I haven't told you yet is that the agglutination reaction, what's really going on is that when antibodies bind to antigens and when this clumping occurs, what happens now is that macrophages come along and they destroy the foreign substance. So the whole idea is that these antibodies identify foreign things, and then other cells will come along that will destroy these foreign cells. The problem is, before those foreign red blood cells are destroyed, they blocked the blood vessels and they have blocked the blood flow, and tissue damage could have occurred. There's one more disease that you may have heard of that's related to blood typing. This has to do with an incompatibility of the Rh group. Again, if you have Rh positive blood, that means you have inherited the Rh antigen. If you have Rh negative blood, it means that you did not inherit this Rh antigen. There's a disease called HDN, hemolytic disease of the newborn, or erythroblastosis fetalis. And let's take a look at what this condition is about. I'm going to skip over this for a second. We'll come back to this. So this is a condition that happens in women in their second or more advanced pregnancies. This does not happen during the first pregnancy, but let's say mama is Rh negative. Mom has to be Rh negative for this condition to occur. So mother is Rh negative. That means that she has A negative blood, O negative blood, B negative blood, AB negative blood. She has one of the negative blood types. The father was Rh positive. The baby inherited that Rh positive factor, so the baby is Rh positive. During pregnancy, it's very normal that some of the fetal blood will reach in and get into the maternal circulation. That foreign blood is now going to set up a immunological reaction. Now, in the first pregnancy, nothing goes wrong. But in the second pregnancy, it's almost like the mother's been vaccinated against Rh positive, and the mother will now create a rather significant immune response against the fetal red blood cells. And as a result, the mother's immune system destroys the baby's red blood cells. Now, this can be treated with transfusions if it is understood, but it also can lead to death of the fetus. So let's look at what happens in a visual idea. So mama is Rh negative. The baby is Rh positive. This is the first pregnancy. It's fine. Some of the baby's blood's going to come out and get into the mother's circulation. It's like the mother has been vaccinated or has been primed, right, to create immune responses against the Rh factor. So in the first baby, everything's fine. Second, and so as a result, right, mama now carries these antigens against Rh. That's fine. That means that she is very much ready to fight off the next time her body sees Rh positive blood. So in that next pregnancy, now it doesn't have to be the next pregnancy, but it has to be the next pregnancy where the baby is also Rh positive. So if the second baby was Rh negative, the third baby was Rh negative, the fourth baby was Rh negative, nothing would be wrong. But the next time that an Rh positive fetus comes along, her antibodies have the ability of crossing the placenta and coming in and attacking the baby. So that can be a fatal condition for the baby if not understood and caught. Now, typically now, if a mom has good prenatal care, regardless of who the father is, if the mother is Rh negative, she's going to receive a extra shot in her pregnancy, and then one right after birth called RhoGAM. And basically that is going to eliminate this reaction from occurring. So let's talk about blood typing for a second. And there are 5 questions that you need to be able to answer when it comes to blood typing. This is the real take-home lesson from this lab. So I need you to understand that antigens are the molecules that we inherit on the surface of our red blood cells. Now, they're all over our body, but in this case, we're talking about the antigens on the red blood cells. And we're referring to the antibodies, these protein molecules that your body makes to fight off foreign antigens. And when an antigen and an antibody meet that are of the same type, it causes an agglutination, a clumping reaction. So there are 8 different blood types, right? There's A positive, A negative, B positive, B negative, O positive, O negative, and then there's AB positive and AB negative. And here are the 5 questions I want you to be able to answer for each of the 8 blood types. Number 1, what antigens are present on the surface of the red blood cells? Number 2, for each of these blood types, what antibodies would this individual produce? Number 3, from whom can blood not be received? 4th question, from whom can blood be received? What blood types can this person receive? And then finally, to whom can blood be donated? I did post in the lab folder a Nobel Prize blood typing game. So if after this presentation this is still not making sense, check out that game. It's kind of fun, and I think it'll drive home what's going on here. So what I'm going to do is just put out a big whiteboard here. And in this whiteboard, I'm going to draw a big red blood cell. Okay? So I'm going to draw a big red blood cell, and here it is. Let's answer these. So here is a red blood cell, and I'm going to answer those 5 questions, and we're going to first answer those questions related to A positive blood. So those 5 questions. The first question is, what antigens would a person with A positive blood have inherited from their parents? And the answer is that on the surface of their red blood cells, there would be the A antigen, and they would also have the Rh antigen because they have positive blood. So that's the answer to question number 1. Question number 2, what antibodies would their body make if they have A positive blood? What do they not have? They did not inherit the B. And so their body, their immune system would make antibodies against B, anti-B. That's the answer to number 2. Question number 3. I'm going to draw an inward arrow with an X in it. What can people not receive? So if you have A positive blood, what blood type are you not allowed to receive? Well, look down to answer number 2. If you have antibodies against B, you would not want to receive any blood that had B in its name. If you did, that blood would agglutinate and would clump. So you would not be able to receive B positive, B negative, AB positive, or AB negative blood. These 4 blood types would not be allowed because if they were to enter into a person with A positive blood, it would cause an agglutination reaction. Question number 4, inward arrow. Question number 4, what can they receive? Well, they can receive the other blood types. So a person with A positive blood can receive A positive and receive A negative. They can also receive O positive and O negative. So these are the 4 blood types that this individual could safely receive. The 5th and final question is, to whom can they donate? So I'm going to draw an outward arrow. They can give their blood to whom? The way to think about this is, when a person with A positive blood goes to the blood bank and donates blood, they are giving the blood bank blood that has the A antigen and the Rh antigen. So the people who receive this blood must already have both of those things in their blood type. They must have the A and the Rh antigen. Well, what 2 blood types have both the A and the Rh? A and AB positive. So a person with A positive blood can donate to the individuals who have A positive and AB positive blood. So I've been through this once. I'm going to do it one more time for you. And I recommend that you, in the next week, take a blank piece of paper, listen back over this presentation, and repeat this with the other blood types. So let me clean up this board. And we're going to do the same thing now, but this time for B negative. So find some clean space on some paper. And let's go through this exercise one more time for practice. And this time we're going to answer the same 5 questions for B negative blood. So question number 1. What antigens would be on the surface of B negative red blood cells? And the answer is just the B antigen. Question number 2. What antibodies could the body produce? Well, the body would produce anti-A, and the body has the potential of making as well anti-Rh. So in this case, this person has 2 different antibodies floating in their blood that could potentially fight off foreign blood types. Question number 3, inward arrow, X in it. What can I not receive? Well, if I have antibodies against A, it means I cannot receive any blood with A in its name. So I could not receive A positive, A negative. I could not receive AB positive or AB negative blood. Those 4 blood types are on the no-no list because they have A in them. But I also cannot receive any positive blood types, any Rh factor. So in addition, I also could not receive B positive or O positive blood. So these 6 blood types are excluded as possibilities if I have B negative blood. Question number 4, though, from whom can I receive blood? So question number 4, inward arrow. I could receive blood from the other blood types, that is, B negative, giving to B negative, that seems very natural, doesn't it? And also O negative. Recall O negative is that universal donor. You're always going to find O negative blood here as a portion of your answer to question number 4. Then finally, when giving your blood away, you are giving away the B antigen. So the folks who receive this blood must have B in their blood type. So that would include B positive, B negative, AB positive, and AB negative. When you are learning this blood typing activity, please do not try to memorize. You have 8 different blood types, 5 different questions. That's 40 little tidbits of information. And trust me, that becomes very, very difficult to memorize a bunch of little negative and positive signs and ABs and RHs. So I really encourage you to draw out the circle, think through the questions. If you work through this logically, you'll always get the right answer. If we try to memorize this, if you're like me, your memory will fail. And so you'll end up killing somebody, to be very blunt. So please be sure to work through this, and your lab instructor will be pleased to also work through blood typing, and perhaps they have a slightly different way of doing it. Also be sure to ask your SI instructor for the way in which they think about blood typing.